Okay, so the next unit we're going to talk about is just all about polynomials, and so just make sure that we understand, what is a polynomial, what's the terminology, the vocabulary that goes along with polynomials, and then just how to do basic operations, right? Add, subtract, multiply, and divide polynomials. And you already know how to do most of this stuff. So add, subtract, multiply, you should know how to do those things already. Division, that's a little trickier, so we'll spend a few days on that. But there's some shortcuts, and there's some nice what do they call it, algorithms that you can use to evaluate and divide polynomials, which are actually, they're pretty neat. I think they're kind of cool. Anyway, so our goal today, we're just adding, subtracting, and naming polynomials. So we already know how to add and subtract. We'll do a little bit of review on that, but mostly we're just going to talk about naming polynomials. Again, most of that's review. So we talk about the degree and the number of terms. We're going to add and subtract polynomials, and then our essential question is, how do we determine the degree of a polynomial? So we start with what's called a monomial, right? Monomial is just a single term, and we call it, a term is a product of a number and one or more variables. Okay, so it's the product or a quotient of those, right? So so we look at all of these examples over here. These are all examples of monomials. Okay, all different kinds of things going on, but they're all the product or quotient of a number and some variables. And so we x squared is the product of two x's. 4, even though there's no variables with that, we still call that a monomial. Here we've got 2, and we've got x's and y's multiplied together, but still, since it's all multiplication, that's a single term, we call that a monomial. Dividing by a variable here, multiplying two variables again. And here we have a variable with a negative exponent. Again, it's the same concept. We're just multiplying or dividing numbers and variables together, so those are monomials. So the only one on this page that's not a monomial is this. And so if we have this x plus 2, it's that plus right there that makes it not a monomial. This is actually two monomials that are being added together. So that's not a monomial. And then we talk about a polynomial. A polynomial is just when we combine a bunch of monomials. Okay, so we add or subtract a bunch of monomials, that makes a polynomial. So when we talk about polynomials, we can talk about the number of terms in a polynomial. And so a monomial is a single term, binomial is 2 terms, trinomial is 3 terms, and anything above that we just simply call a polynomial, and we say how many terms are in it. So if I look at this right here, here I have 1, 2, 3, 4, 5 terms in that. Right? I can't combine any of these terms. There's no like terms in here. So I've got 5 monomials in there. So we'd call that a polynomial with 5 terms. Okay, so we'll have a polynomial with 5 terms, polynomial with 4 terms, polynomial with 6 terms. The only special names we have are just for 1, 2, and 3 terms. So monomial, binomial, and trinomial. And then we can also talk about the degree of a polynomial. And so when we look at the degree, what we're looking at is the largest exponent of one of the variables. If there's just one variable, it's just the biggest degree, the biggest exponent. If there's multiple variables, it's the sum of those exponents that are being multiplied together. So so here we have there are no exponents here, right? There's just a number, there's no variable. So we call this a 0 degree, or we call this a constant. And so this is a constant monomial right here. If it is just an exponent of 1, we call that a linear. If we graph that, it would make a straight line. Degree 2, we call a quadratic. So here's x squared, that's a quadratic, right? It's degree 2, exponent of 2. This one here is also a quadratic, it's 4xy. Even though those exponents are 1, they're being multiplied together. So this is 1 and 1, that would be 2, that would be a quadratic. So the 4xy is a quadratic. Cubic is a 3rd degree. Quartic is a 4th degree. And then a quintic is what we call something that's degree 5. Now in this example right here, even though there's 2 terms there, right, this is a binomial, the degree of the biggest exponent here, right, the biggest exponent is 5, so that we call that a quintic polynomial. This would be actually a quintic binomial, this one right here. And then this one, again, we've got variables that are being multiplied together. So I've got an x squared and a y to the 3rd, and so I just add those 2 and 3 together, and that's a 5th degree term. It's degree 2 and degree 3, so it's a 5th degree term, so that would also be considered a quintic. Now the ones that people get confused on are this one and this one, because they sound really similar, right? So quartic, 4 quarters in a dollar, 4 quarts in a gallon, right? It means 4. Quartic is 4. Quadratic, when you talk about quad, they're talking about a quadrilateral, and so the reason that comes up in this term, or in this type of polynomial, is when we go to find the area of, you know, a rectangle or a square or something like that. If we find the area of a quadrilateral, it usually involves, you know, multiplying 2 things together. So that's where the quad becomes 2. It has to do with finding the area of it. But a lot of people confuse those, right? So quadratic is 2. Think about squares here, and then quartic is 4. So think about dividing something into quarters, right? So we have the number of terms, right, and then we have the degree, and so we put those 2 things together, and that's how we name a polynomial. And so when we name a polynomial, we just talk about the number of terms and the degree of that. And then the other thing we'll talk about is standard form. So standard form is just simply written from the highest degree to the lowest degree. So if I were just to mess this up here, right, make up a new, let's switch these 2, there we go. Okay, so there's nothing wrong with that polynomial, but it's just not organized very well. So when we write out a polynomial, right, as an answer, or, you know, we're working with it, we generally want to try to organize that in a cohesive way. So we'll start with what they call standard form. We start with the biggest degree, right? So my 3rd degree here, my cubic term, is my largest degree, and so cubic, and so now I want to put my quadratic terms, and I've got 2 of them. And it doesn't really matter which one goes first. I'll put this one first. Move that around there. But it doesn't really matter which one comes first. So here I have my 2 quadratic terms, and then my linear terms would come next if I had any, and then my constant terms. So we'd call this standard form. So it's just largest degree to smallest degree. And then we have what's called the leading coefficient. The leading coefficient is just in standard form. Whoops. In standard form, it's just the number in front of that. And so we'll be using that leading coefficient to help us understand how this graph behaves, right? How that function behaves, what are the end conditions, and that sort of stuff. So we call that leading coefficient. But it has to be in standard form. So we would call this it'd be a cubic, right? Cubic, a polynomial with 5 terms. The leading coefficient is 2. So here's an example here that we write it in standard form, and we want to name that polynomial by the degree and the number of terms. And so put it in standard form. I'm going to put the largest degree first, so it would be my cubic term, and the quadratic term after that. There's no linear terms, so you skip those, and then I've got the constant term there. So this would be a cubic trinomial. So 3rd degree, 3 terms, cubic trinomial. For this one, there's only 2 terms in it, so we have a binomial, but the x to the 4th term should come first, and that negative stays with that, right? So this is negative x to the 4th plus 2. So this would be a quartic binomial. I thought that I had... Give me 1 second here. Thought that I had reset this, but I guess I didn't. So, so when we're adding and subtracting polynomials, all we're doing is we're combining like terms. There's nothing fancy about what we're doing here. We're just combining like terms. But as we get complicated polynomials, and there gets to be a lot to kind of keep track of. So there's a couple of ways that they talk about organizing these problems. One is they talk about what's called the vertical form, and all that means is you just line up the terms vertically. So if I were to add these together in vertical form, I would just line up all my cubic terms, line up all my quadratic terms, linear terms, and so forth. So I don't have any other cubic terms, but I have another squared term there, quadratic term. Line those up, line up my linear terms, line up my constant terms, and then I would just add those together. And so I've got negative 3x cubed, negative 2x squared, negative 2x squared. This is negative 4x squared. Please do not add those exponents, right? We're not multiplying these things together. We're just adding. We're just counting. Right? How many x squareds do I have? Well, I have negative 2 and negative 2. When I add those together, I get negative 4. Same thing here. I've got 5 x's and 7 x's. Gives me a total of 12 x's. And the constant term 4 and negative 6 gives me negative 2. So that would be my sum there, and this is using that vertical format for lining those up. If we were asked to name this, this would be cubic, so degree 3, and it's a polynomial with 4 terms. So we have a cubic polynomial with 4 terms. The leading coefficient here would be negative 3. Then they talk about horizontal form. Horizontal form is the way I think most people do this. And again, it's just a way of kind of organizing so that you make sure that you've included everything, that you've done all the distribution, that you've got everything included in you miss any terms or anything like that. So it's just an organizational way of doing this. So again, I'm going to start with my largest term, right? My largest degree term. So I've got x cubed here. So I'm going to write that out, negative 12x cubed. Okay, so I'm done with that one. I like to cross them out just to make sure that I got them. That's a 3 right there. I don't have any other cubic terms, so I'm going to go to my quadratic terms. So here I've got 4x squared. And then I've got an x squared here, but I've got this negative, so this is minus, I'm subtracting here, so this is minus negative x squared, so this is plus x squared. Again, is an area where a lot of mistakes happen, right? Really common for people to drop that negative or forget to distribute. So I've got that, I've got that. Go to my linear terms, I've just got the 1. So again, this is negative x, right? Don't just take the x, it's subtracting, so it's minus x. So I'm done with that. And then the last thing I have is just my constant terms, so I have a plus 2 here. And then this is going to be negative 4. I'm subtracting 4. And then I can just go through and combine my like terms. So I've got some like terms there, the x squareds, and I've got some like terms there with the constant terms. So I end up with negative 12 x cubed plus 5x squared minus x minus 2. Okay. And always a good idea to just kind of do some checking here, just making sure that you didn't drop a term somewhere, you didn't write down a negative instead of a positive, or vice versa, that you combined all your like terms together. So this is the same idea. I could do this in vertical form or horizontal form. So if I were to do this one, I'd start with the largest term. I've got a quartic term there, so negative 3 x to the 4th. Go to my cubic terms. Just got the 1, so I got minus 3x cubed. Go to the squared terms. I got 5x squared. Here I've got a negative, so I got positive 2x squared. That one done, I got that one done. Go to my x terms, my linear terms, I got negative 4x and negative 7x. So those are done. That's done. And I've got 4 here. And I've got negative 6, so that'll be plus 6. So just reorganizing and putting them in order, and now I can combine like terms. So I've got like terms there, I've got like terms there, I've got like terms there. Alright, so again, we're just combining like terms. That's really all we're doing, organizing and combining like terms. So this would be a quartic polynomial with 5 terms. And that leading coefficient of negative 3. So this is kind of more of the same. I'm gonna skip this one. Move on to this one. So this one here, they're asking you to write a polynomial expression for the perimeter of this triangle. So perimeter just means you're going to add together all the sides. And so I'd have x squared plus 4. So the first side there. This second side, I'd add x to that. And the third side, I would have x plus 2. So this is one side, second side, the third side. So the area of that triangle would be written like that, and then we'd want to simplify that and put it in standard form. So this would be x squared. Okay, and my x squared terms, I've got 2 x's plus 6. So I can find the area of that triangle by that equation. Alright, so that's pretty much it. In your assignment today, you're going to be asked to to do some naming. There's a few questions that ask about names, and they ask about like what's the name of this term, what's the leading coefficient of this term, and so there'll be some naming stuff, and then most of them are just going to be addition and subtraction. Hopefully it goes pretty quick, and that's pretty much it. Any questions anybody has about anything? I'll post the notes for this, and I'll post the video for this here in just a few minutes.